Imagine dropping a heavy toolbox onto a plastic storage container. You expect it to crack. Instead, it survives without a scratch. That simple box sitting in your garage or under your bed has traveled thousands of miles and survived incredible heat, crushing pressure, and one of the most precisely controlled manufacturing processes on Earth. Most people never think about this, but every storage container begins its life deep underground, long before it ever reaches a factory. Today, you're about to follow that hidden journey from the Earth to your home, and what happens next surprised even experienced engineers. Think about this. Every year, manufacturers produce well over 2 billion plastic storage containers around the world. Some organize homes, others protect medical supplies, military equipment, and even life-saving emergency gear. Together, they represent a global industry worth tens of billions of dollars. Yet despite their importance, almost nobody sees the extraordinary factories where these everyday products come to life. We're about to enter one of those factories. You'll witness giant machines melting tiny plastic pellets into glowing liquid, steel molds closing with thousands of tons of force, and robots moving faster than the human eye can comfortably follow. You'll hear the constant roar of hydraulic systems, smell the faint scent of warm polymer, and watch ordinary raw materials transform into something built to last for decades. But before any of that can happen, we have to travel back to where the journey truly begins. Believe it or not, the story starts nearly 2 kilometers beneath the Earth's surface. Crude oil and natural gas, trapped inside ancient rock formations for millions of years, provide the building blocks for most plastic storage containers. Huge oil fields in Saudi Arabia, the United States, Canada, Qatar, and the United Arab Emirates supply enormous amounts of these raw resources. Every single container begins with carbon atoms that nature assembled long before humans even existed. After extraction, the crude oil travels hundreds or even thousands of kilometers through pipelines, rail cars, and massive ocean tankers before reaching a refinery. Inside these enormous industrial complexes, towering distillation columns heat crude oil to around 370 degrees Celsius, or nearly 700 degrees Fahrenheit. Different hydrocarbons separate into layers according to their boiling points. One valuable fraction, called naphtha, becomes a starting point for many everyday plastics. But here's what nobody tells you. Naphtha isn't plastic, not even close. Engineers feed it into giant steam crackers operating at temperatures approaching 850 degrees Celsius, or more than 1,560 degrees Fahrenheit. In just fractions of a second, intense heat breaks large hydrocarbon molecules into much smaller building blocks like ethylene and propylene. Those tiny molecules become the foundation for the plastic you use every day. Next comes one of chemistry's greatest transformations. Inside carefully controlled reactors, billions upon billions of ethylene molecules join together through polymerization, forming incredibly long chains known as polyethylene. For heavy-duty storage containers, manufacturers often choose high-density polyethylene, or HDPE, with a purity exceeding 99.9%. This remarkable material combines low weight with exceptional impact resistance, making it perfect for containers expected to survive years of abuse. The finished polymer cools into tiny pellets, each only a few millimeters across. A single pellet weighs almost nothing, yet one medium-sized storage container may require more than 1,500 of them working together. These smooth, glossy pellets flow like dry grain into giant silos capable of storing hundreds of tons. Listen carefully, and you'll hear them pouring through steel pipes like a waterfall made of tiny beads. Color doesn't appear by accident, either. Before manufacturing begins, technicians blend the natural white pellets with concentrated master batch pigments. Black containers often contain carbon black for UV protection, while blue, red, or green versions rely on highly engineered color additives that resist fading for years. At the same time, manufacturers mix in antioxidants, UV stabilizers, and processing aids, usually less than 2% of the total material, yet absolutely critical for long-term durability. Most people never realize how global the supply chain really is. Raw petroleum may come from the Middle East, additives from Germany, pigments from Japan, molds from China, and final assembly in North America or Europe. Before one storage container reaches a store shelf, its materials may have traveled more than 20,000 kilometers, crossing multiple oceans and continents. And that's before the real engineering challenge even begins. Of course, this journey comes with environmental challenges. Producing virgin plastic consumes energy and releases greenhouse gases, which is why many manufacturers now blend recycled HDPE into selected products without sacrificing strength. Advanced recycling plants clean, shred, wash, and remelt used plastics into pellets that meet strict industrial standards. It's a remarkable second life for material that might otherwise become waste. Now the pellets are clean, blended, tested, and ready for the factory floor. Thousands of kilograms wait silently inside towering storage silos, prepared for a journey that will last only a few minutes but demand astonishing precision. In the next stage, those tiny beads will disappear into machines powerful enough to squeeze molten plastic with thousands of tons of force. And once you see what happens inside those steel molds, you'll never look at a plastic storage container the same way again. The moment has finally arrived. Thousands of tiny plastic pellets leave the storage silo and rush through vacuum pipes to one of the most powerful machines in the entire factory. The pellets disappear into a large steel hopper mounted above the injection molding machine, where computerized sensors measure every kilogram with incredible precision. Imagine standing beside it. You hear the steady hiss of compressed air, the rumble of hydraulic pumps, and the constant clicking of automated valves preparing for the next cycle. In less than 2 minutes, these ordinary pellets will become a finished storage container. Inside the barrel, a giant rotating steel screw begins pulling the pellets forward. This screw measures nearly 2 meters long in many industrial machines and spins between 80 and 150 revolutions per minute, depending on the size of the container. Powerful electric heaters gradually raise the temperature from room temperature to around 220 to 250 degrees Celsius, or 428 to 482 degrees Fahrenheit. Friction between the pellets and the rotating screw adds even more heat, until the solid beads soften into a thick, glowing stream of molten plastic that moves like warm honey. But here's what nobody tells you. The machine doesn't simply melt plastic. It carefully removes every tiny air bubble before injection begins. Even a bubble smaller than a grain of sand could weaken the finished container or leave visible marks on its surface. Pressure inside the barrel climbs to nearly 2,000 bar, or almost 29,000 psi, storing enormous energy before the machine releases it in a fraction of a second. What happens next looks almost explosive. Suddenly, the injection phase begins. The screw lunges forward like a giant piston, forcing molten plastic through a narrow nozzle and into a precision machine steel mold. The plastic races through intricate channels at speeds exceeding 300 millimeters per second, filling every corner before it is time to cool. The entire injection process usually takes only 3 to 8 seconds, yet every millisecond matters. Miss the timing, and the entire part becomes scrap. Now comes one of the most powerful moments in the factory. Before injection begins, enormous hydraulic or electric clamping systems squeeze the mold shut with forces ranging from 500 to more than 2,500 tons, depending on container size. That's enough force to crush several family cars at once. Without that incredible pressure, molten plastic would burst from a mold like lava escaping a volcano. Instead, every drop stays exactly where engineers intended. Inside the mold, something remarkable begins to happen. Cooling channels carrying water at approximately 15 to 25 degrees Celsius, or 59 to 77 degrees Fahrenheit, rapidly remove heat from the molten polymer. In just 20 to 60 seconds, depending on wall thickness, the liquid plastic hardens into an incredibly strong solid. You can almost hear the quiet crackling as the material shrinks ever so slightly, gripping every microscopic detail engraved into the polished steel surface. What happens next surprised even experienced engineers. The mold slowly opens, revealing a perfectly formed storage container that only moments ago existed as thousands of loose plastic pellets. Powerful ejector pins gently push the container free, while robotic arms move into position almost instantly. Every movement follows computer-controlled, timing accurate to thousandths of a second. The entire production cycle repeats again and again, sometimes more than 600 times during a single shift. As the container leaves the mold, workers and automated systems immediately inspect its appearance. Thin plastic runners and gates left from the molding process are trimmed away using precision cutters or robotic trimming stations. The cut edges must remain smooth because even a tiny burr could interfere with lid sealing or stackability. Every trim piece falls onto conveyor belts where it will be ground up and recycled back into production. If the container includes locking handles, wheels, or transparent lids, another production line begins its work. Automated assembly robots install hinges, snap fit latches, rubber seals, and reinforce handles with remarkable speed. Some assembly systems complete more than 1,200 installations every hour, while vision cameras verify that every component sits perfectly in place. The rhythm of moving robots, clicking mechanisms, and conveyor belts create a mechanical symphony unlike anything else inside the factory. By now, what started as tiny pellets has transformed into a durable storage container capable of carrying heavy tools, clothing, food supplies, or industrial equipment for years. But manufacturing isn't finished yet. Before a single container earns a right to leave the factory, it must survive punishing tests designed to expose even the smallest weakness. Some containers will be dropped, crushed, twisted, and frozen, all on purpose. And that's where the story becomes even more extraordinary. The factory may have already shaped the container, but now comes the part that determines whether it deserves to carry the manufacturer's name. Every finished container enters a high-tech quality control area where computers inspect details too small for the human eye to notice. Bright white inspection lights flood the production line, while cameras capture dozens of high-resolution images in less than a second. Most people never see this room, yet it's where the toughest decisions happen. As each container passes beneath the cameras, artificial intelligence compares it against a perfect digital model stored inside the factory's computer system. The software checks hundreds of measurements, including wall thickness, lid alignment, handle position, and surface finish. Laser scanners measure dimensions with tolerances as tight as plus or minus 0.20 millimeters, while defect detection systems can spot scratches, sink marks, or tiny bubbles smaller than a grain of rice. The entire inspection takes less than 2 seconds. But here's what nobody tells you. Even factories with incredibly advanced equipment still reject products every single day. A slight color variation, an incomplete corner fill, or a warped lid can send a container straight into the recycling system. World-class factories often keep rejection rates below 1%, but that still means thousands of imperfect containers never leave the building. Instead of becoming waste, nearly all of that plastic gets shredded, remelted, and transformed into new products. Now, the containers face something even more brutal. Automated drop test machines repeatedly release them from heights of 1 to 2 meters, both empty and fully loaded with heavy weights. The impact echoes through the testing laboratory as plastic slams against reinforced concrete and steel platforms. Engineers carefully inspect every corner for cracks, broken hinges, or damaged locking clips. What happens next surprised even experienced engineers. Many premium containers survive dozens of impacts without failing. Strength isn't enough on its own. Some containers enter powerful compression machines that apply loads exceeding 500 kilograms, while others twist under torsion tests that simulate years of real-world use. Specialized environmental chambers expose product to temperatures ranging from minus 30 degrees Celsius to 60 degrees Celsius, or minus 22 degrees Fahrenheit to 140 degrees Fahrenheit, proving they can survive freezing winters and scorching summer garages. Every successful test builds confidence that the container will protect whatever you place inside it. The factory also checks how the containers perform after years of sunlight. Powerful ultraviolet lamps recreate months of outdoor exposure in just a few days. Engineers compare faded samples with freshly molded ones, searching for color changes, brittleness, or weakened surfaces. Special UV stabilizers mixed into the plastic during production help prevent cracking, keeping premium containers strong even after years beneath bright sunlight. Despite all this automation, one step still depends on human experience. Skilled inspectors remove random samples from the production line and examine them by hand. Their fingertips detect tiny imperfections that cameras sometimes miss, while years of experience help them recognize subtle changes in texture, flexibility, and finish. Even in one of the world's most advanced factories, human judgment still beats machines in ways engineers deeply respect. Only after passing every inspection does each container receive its final approval. Automated labeling systems print production dates, batch numbers, recycling symbols, and traceability codes that allow manufacturers to identify exactly when and where every container was made. Conveyor belts carry the approved products toward robotic packaging stations, where stacks of perfectly finished containers wait for shipment across the globe. You might think the journey ends when the boxes leave the factory, but that's only part of the story. These ordinary-looking containers have become a global product worth billions of dollars, connecting chemical plants, factories, shipping ports, retailers, and millions of homes around the world. And the numbers behind this industry are far bigger than almost anyone imagines. In the next chapter, you'll discover the incredible scale of plastic storage container production and 3 astonishing facts that change everything. Now that you've seen how a single plastic storage container comes to life, imagine that same process happening every second in hundreds of factories around the world. From North America to Europe and across Asia, injection molding machines run day and night with barely a pause. Together, they produce well over 2 billion plastic storage containers every year, enough to give one to nearly every 4th person on Earth. The scale is almost impossible to picture until you see it in action. Think about this. If all those containers were stacked one on top of another, the tower would stretch far beyond the edge of Earth's atmosphere. Placed side by side, they could cover thousands of football fields. Every hour, countless trucks, cargo trains, and container ships carry these products towards stores, warehouses, hospitals, schools, factories, and homes. Most people never notice this invisible supply chain, yet modern life depends on it every single day. The global plastic storage container market now generates an estimated 20 to 30 billion US dollars every year, and demand continues to grow. Home organization trends, booming e-commerce, industrial logistics, and expanding warehouse automation all require stronger and more durable storage solutions. Experts expect the market to grow steadily throughout the next decade as manufacturers introduce lighter materials, smarter designs, and more sustainable production methods. What once seemed like a simple household item has become a massive global business. China leads the world in plastic product manufacturing, producing roughly 35% of the global supply. The United States follows with approximately 15%, while Germany, Japan, and India remain among the other major manufacturing leaders. Thousands of factories across these countries operate around the clock, supplying products that travel to nearly every nation on Earth. Every container represents the combined effort of miners, chemical engineers, machine operators, designers, logistics experts, and quality inspectors working together across continents. Behind every container stands an enormous workforce. Worldwide, millions of people work throughout the plastics industry, from petroleum extraction and chemical refining to mold design, machine manufacturing, quality control, packaging, transportation, and recycling. Even the steel molds used to shape these containers require highly skilled toolmakers who may spend months polishing and machining a single production mold. It's a level of craftsmanship most people never imagine when they open a storage box at home. The story stretches back much further than many people realize. Early plastic storage containers appeared during the 1950s, when stronger synthetic polymers became widely available after World War II. Those first designs look simple compared to today's products, often lacking reinforced corners, locking lids, or UV protection. Over the next 70 years, better materials, computer-aided engineering, and precision molding transformed them into incredibly durable products capable of lasting for decades under heavy daily use. Did you know? Some industrial plastic storage containers can safely support more than 500 kilograms without collapsing when properly designed. Did you know? Premium injection molds often cost over $1 million US dollars, yet they may produce millions of identical containers before retirement. And here's perhaps the biggest surprise of all. Many modern containers already include recycled plastic without most users ever noticing the difference in strength or appearance. But the future promises even greater changes. Engineers are developing plastics made partly from renewable plant-based materials, while artificial intelligence continues improving factory efficiency and reducing waste. Advanced recycling technologies now recover plastics that once ended up in landfills, giving them a second and sometimes even a third life. The next generation of storage containers may become stronger, lighter, smarter, and significantly more sustainable than anything produced today. And after everything you've seen, one final journey still remains. Take one last look at that ordinary plastic storage container sitting on a shelf. Just a few minutes ago, you followed an incredible journey from ancient oil and natural gas buried deep beneath the Earth's surface to advanced chemical plants, where molecules transformed into strong polymer chains. You watched millions of tiny pellets melt into glowing liquid, race through steel molds under thousands of tons of pressure, cool into a durable shape, and survive some of the toughest quality tests modern engineering can create. What seemed simple on the outside hides one of the most sophisticated manufacturing stories in the world. Think about this. Every scratch on a storage container tells a story of strength engineered into its walls. Every perfectly fitting lid reflects the precision of computer-designed molds measured to fractions of a millimeter. Every reinforced corner represents decades of research, testing, and innovation. Most people see only a plastic box, but now you can see the hidden science, the enormous machines, and the skilled people who made it possible. Factories around the world will continue producing thousands of these containers every hour, helping organize homes, protect valuable equipment, transport industrial components, and safeguard emergency supplies. Behind every finished product stands an invisible network of miners, chemists, mold makers, machine operators, quality inspectors, logistics experts, and recycling engineers working together with remarkable precision. Their work rarely makes headlines, yet it quietly supports everyday life across the globe. As technology advances, the next generation of plastic storage containers will likely become even stronger, lighter, and more environmentally responsible. Artificial intelligence will optimize production, smarter materials will reduce waste, and advanced recycling systems will keep valuable plastics in circulation instead of sending them to landfills. The future of manufacturing isn't just about making more. It's about making better. And this is only one chapter in the extraordinary world of modern industry. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.